the next speech is perfect for you. Please welcome from Utrecht, Sirisha Guduru, and from Berlin, Artem Turobarov, both senior cloud engineers from CLYSO. In the session Beyond Backup S3 Data Management, they will show you how real teams manage S3. You will get a deep dive into Ceph RGW Lifecycle Policies for intelligent tiering to tape or cloud and on production to the open source tool Chorus in a large-scale S3 moves. Welcome, Sirisha and Artem, please.
Hello. Yeah. Good afternoon, everyone. I hope we had great sessions till now. Thank you, Benedict, for giving an insight into that. But yeah, so I think today we are talking about S3 data management with tiering, and we also would like to talk about Chorus. Myself, Sirisha, I've been working with CLYSO for almost 3 years now, and I have experience with working on high-end and storage clusters. And yeah, I talk to a lot of people, talk about a lot of problems, issues, fixing, and do a lot of stuff, being part of CLYSO. And I have my colleague Artem here, who is co-presenting with me today. Yeah, so we all have different set of workloads on our S3 workloads on our clusters, right? So we all do plan backups, disaster recovery, and failure strategies. So we do a lot of things. So, and some are manually driven, like we just run behind the scenes, taking backups, making sure our data is safe. So our workloads include a lot of different varieties, like hard paths, like there is compliance retention, there is analytics, we use it for a lot of things here. So snapshots and backups are right now not alone enough for our day-to operations. So I believe lifecycle migrations for partial recall, selective restore, there's a lot that we can do more than backups with less intervention. And a lot of teams today want to move their data automatically and bring it when the applications really need them and restore them when needed, and just keep it away from the faster access just to keep data safe behind the scenes, but get it when needed. So today I would like to talk about various strategies here, but I know we all are fans of RGW multi-site, right? So, multi-site, it's just here, but I'm not going to talk about it deeply. But today I'm going to concentrate on the tiering model, where we use placement targets, storage classes, life cycles, transitions, and policies. And I think I got an opportunity to test tape library simulator with point archival gateway as a cloud storage, in the cloud tier for external endpoint. And we also will briefly touch upon the retrieval patterns, and we will focus on Chorus, our in-house tool. So multi-site. So we use multi-site just for geo. It's a great product from Ceph itself for geo-isolation and disaster recovery, where the entire lifecycle and placement are applied within a zone. Multi-site replicates the data and metadata across zones, but our focus is not that for today. So let me just take you to the tiering concepts. Like we know since for more Ceph versions now, we have been using storage classes, placement groups, different pools to transition our data into. So here, placement targets basically map a bucket or object class to pools. So the hot data can be on NVMEs, like it really depends on the infrastructure that we have in the Ceph cluster. So hot is on NVMe, warm can be on HDD, cold on HDD as well with erasure coding. And lifecycle policies, they are driven by age, drags, prefixes. You can set your policies however we want. And then storage classes, they give control on the lifecycle transitions. Basically, we achieve it with storage classes. So I have an analogy here. Hot is like espresso, cold is like, something, a cold coffee, but then archival tier is something like you leave coffee on a Friday and you come back on Monday looking for it. So yeah. Okay. So tiering here, like I have a bucket, there is a lifecycle policy based on the age of the bucket, or the objects inside the bucket, you move between different tiers. And yeah. Let's talk about designing a practical tier plan here. This is just an example. Again, it really depends upon what infrastructure we have behind the scenes, but for hot, you can consider having SSDs or NVMEs on a replicated pool if we can afford. And warm, again, on HDD, but still index on HDD as well. So erasure coding is kind of considered here for cold tier because it just occupies less space when compared to replicated. So yeah. Archival here, yeah, it's completely outside the Ceph cluster. In the first 3 stages, the data is still residing in the Ceph cluster on different pools though. But for archival, the external endpoint here in this demo is backed by a tape library emulator. You can also use an actual tape. So yeah, as I mentioned, tape library is simulated here and the archival gateway is based on that. So the cloud sync happens to the point here, since I'm using PAG, point archival gateway, the endpoint, which is actually an S3 endpoint. You can use any external S3 endpoint. This is just an example. And the retrieval happens on the restore object API can be called for you to restore or retrieve the object through the get back. And we'll talk about the retrieval options soon. So for this archival tier, you create a new storage class, Cloud S3 example, and that's the type of the tier. And storage class comes with its tier configurations, and then the lifecycle policies are applied on the bucket, and then the transitioning happens. So here, these are examples again. So the JSON looks something like this, but this is based on an AWS CLI, where you actually define the transitions into the storage classes, where there is warm, cold, archive, and we can always define the days in which the data has to move. It depends on our workloads and the clients. So here, for example, this is how I configured the cloud tier for the tape library. The endpoint is a tape library endpoint, simulator endpoint, all of that. I think the topic of interest here is retain head object true. If we configure this in the tier target, what happens is, while your data is transitioning between your Ceph cluster locally and to the tier endpoint, the cloud endpoint, the metadata is still retained in the local cluster, and the actual data is copied, like another object is created and the data is actually copied onto the cloud storage endpoint, but your metadata is still retained in the local cluster. This is the example lifecycle policy that I have applied here. Like probably after 60 days, the data moves to the cloud tier. Now, I think we have spoken briefly about the transitions here. So, yeah. There were a couple of slides that were missing, but I wanted to also talk about the various lifecycle policies that are in use. For example, transition is not the only lifecycle policy. We have expiration, we have transition. And we have policies based on the object sizes, like object size greater than, object size less than. So based on all of this, we can apply the lifecycle policies. And coming to the retrieval patterns, we have two types in which we can retrieve the data back. One is the RestoreObject API and Read-Through GET. So RestoreObject is that's an API that is called on the objects to move again back to the tiers where they were operating to. And one is a temporary restore and the other is the permanent restore. It's just a header change and it depends on that basically. So temporary restore, one point that is to be noted here is like while we are trying to restore it with the RestoreObject API, the data moves from the cloud tier, the cloud storage external endpoint, to the standard storage class back into the local cluster. And for temporary restore or permanent restore, how does it differ is basically with the restore request. So with the restore request header, if you give data, like if I want it only for 3 days or n number of days, so you specify it here, and after which the data moves back to the external storage, and the data lives only for those number of days in the local cluster. So temporary restore basically skips all your lifecycle policies. We might get a doubt like, what if that the data comes back into the standard storage class, and if there is a lifecycle policy on it, what happens to my data? Will it go back? But ideally it wouldn't. For a temporary restore, the lifecycle policies are skipped. It just takes a backstage pass, I guess. And then again, permanent restore, if you don't specify anything in the restore request header, it just thinks that the user wants to permanently move the data back into the local cluster. So the data is, the object is just restored and left there. Then the lifecycle policies do apply and the data is moved back accordingly. There is another option for read-through GET. This is still in the testing phase, where if I have to be able to read the data directly from the cloud storage endpoint, so I allow read-through, I will make it true, and read-through restore days. Again, I define the number of days I'll be able to read that data. So this is another retrieval pattern. So with this here, I would like to call my colleague Artem to speak about Chorus. Thank you.
Yes, Sirisha will be back soon. Yeah, for demo. Will be back for okay. So yeah.
Come back for a demo.
Yeah.
At the end.
Okay, my name is Artem. I'm a software developer at CLYSO, and I'm going to tell you about Chorus, the tool we developed to cover use case beyond S3 lifecycle policies. So yeah, Chorus is an open source, vendor agnostic data management software for object storage. You can follow the QR code to check details on the GitHub, but in the simple words, it's helped to automate backup and migration from any to any S3 storage. So we actually started from a small subset of S3 APIs and extended in every release. And in the end, I have a slide with the table of currently supported vendors and API. So yeah, any-to-any is a wish or marketing, but yeah. Okay, so here we have old storage with the live traffic from the users with the hundreds of buckets, millions of objects. And on the right, we have a new one, which we want to migrate into with like minimal interruptions. And usually we want to split migration into smaller chunks to make it like more manageable for us. So for this, we need a first component, a Chorus S3 proxy. With the proxy, we have ability to route requests to old or new storage depending on the status of the bucket migration. Yeah, and by default, when we just install the proxy, it will forward all requests to old storage transparently. Now we also need the Chorus worker, which is responsible for actual data transfer. So it can utilize multiple machines to speed up migration. It also gracefully handles restart. So you can think of it as a distributed version of the AirClone tool if you use it. So which you can install like in a cluster. Yeah, so to start migration, we need to call Chorus API. You can use like CLI. We also have a small web UI. But here we asked Chorus to start migration for bucket B. So Chorus will go to bucket B in old storage and list all the objects there and put it in existing objects queue. So the goal is to copy all existing objects in the first run, and it may take some time since we have like millions of objects. Meanwhile, users will continue to update objects, delete it, and so on. And as soon as we started migration, proxies will start recording changed object events and put it like in a separate queue here. Yeah. When we have some tasks, our workers will pick up and first will copy all existing objects in parallel, like depending on our configuration, amount of workers, and so on. We can also put a rate limit to not overload like old storage. But in general, first we copy all existing objects and then go through changes and see if we need to update or delete an object. Yeah. Oh, and I forgot the one detail from the previous slide. Here, when we record events, we also maintain version metadata, like not S3 version, but our own. So for example, when we change object in old, we increment version in old. When we copy to new, we also change version accordingly. So we also track it. It will be needed later. Okay, so here we done like with existing objects. And what we have here is a proxy sending events like about changing objects because users are using this bucket. Worker tries to keep up and send data to bucket B in new storage. And this looks almost exactly like a multi-site. So we have like asynchronous replication. So in theory, we can actually stop here. So for example, if we want to have like a disaster recovery use case with two different clusters. One of them is Ceph, other one like is some cloud provider like Minayo or I don't know, something else. And if we actually don't have a plan to switch traffic to new storage because we're not migrating, we don't need a proxy and we can rely on S3 bucket notification to get the changes. So yeah, but we actually want to migrate and we want to switch traffic at some point. And for this, we need to like all the new bucket to be in the same state. So we need like both queues to be empty. So for this, we can call Chorus API again to plan our downtime window. So we can select a start date, like we will start downtime at some point, like on the weekend, in the night, when nobody is writing, so queue will be already pretty empty. We can set some extra constraints, like to start migration if the queue has like very few objects, like less than 5 or something like this. And we can send the timeout for downtime. So for example, if we will not be able to drain queue in time, we will just roll back to old storage and try later. Yeah, and we also have option to do it without downtime. So you remember that proxy maintaining our own metadata. So if we select option to migrate like with the zero downtime, instead of routing per bucket, proxy will try to route request per object. So for example, all write requests, I will go back, all write requests will go to new. And for read request, we will just check an object version. So, and we'll go to the storage with the latest one. So yeah, that's the idea. Yeah, so here we have a downtime window. Worker started downtime and asked proxy to block all requests to bucket B. So it will have a chance to to make bucket in sync. Yeah, after both queue are empty, worker can optionally verify bucket contents. For this, we just list objects in buckets like in parallel, checking like name, size, e-tags. And if everything is okay, we like switch all traffic to new one and like make migration complete. So now we can decommission bucket and bucket B in all storage and start with the next one. Yeah, so right now Chorus supports migration between like any S3 compatible storage like Ceph, MinIO, like of course AWS. It migrates object payload, object bucket metadata tags, ACLs. We also have versioned bucket support. At the moment, version ID is not retained because it's like generated automatically by storage. But yeah, if you're migrating into Ceph or MinIO, you can have the same version ID. So we just merged it into main branch and it will be a next release. We also merged Swift API support. We tested by migrating from OpenStack Swift storage to RGW Swift. And this one also should be next release. So yeah, we want to add like more features. I will not go into details, but besides like new features, we want to like fully cover like well-known S3 and Swift API, and we also want to support some like popular cloud because they always try to like deviate from standards or make their own standards to vendor lock people. And yeah, we also wanted to support it anyway to like help with transition to on-premise like from the cloud. So yeah, I think that was it. And yeah, back to Dima.
I think my demo is a recorded video. Let me just see if I can. Yeah. Okay. Okay. Can you see? Yes. Let me just increase the speed a bit. I think I can understand German. Yeah. Yeah, sure. Yeah. Okay. Yeah, you see me showing the things that I've already talked about, but sure. So this is the Ceph cluster, the local cluster. So here we see various storage classes, the cloud tier, standard, cold, and hot. And standard, cold, and hot being different pools in the same Ceph cluster. Cloud tier is an external endpoint. So here the endpoint, access key, secret, all are configured, and as I mentioned earlier, retain head object is set to true. So our metadata still retains in our local Ceph cluster. So what am I going to do next? Yeah, zone get. Yeah, I wanted to show you how I configured the pools here, like standard, already defined, cold, and hot. So I'm using AWS CLYSO. You see me trying a lot of commands that don't work, so we also know what not to do here. So yeah, so these are different buckets that are existing in my Ceph cluster. Here I'm showing policies, the policies that I defined, like hot, cold, move after 30 days, and then there's another, yeah. Yeah, so here I'm moving it to the cloud tier, just as I showed earlier. Yeah, so this is me applying the lifecycle policies on the buckets. So I've chosen 3 different buckets for different tiers. So yeah, so just to show you how the policy is applied. Yeah, so yeah, it's the same thing. The policy got applied, and we'll be now going to the, sorry. Yeah. This is to verify that the cold storage policy is applied on another bucket, and sorry, I use my name in the bucket. I hope that gives me some luck. Yeah. So I think now we are changing the policy on this bucket to be the tape endpoint. Like we are moving it to the archival tier. So yeah. Now let's go back to the Ceph cluster and see how the LC processes threads got triggered. So we have the last 3, like uninitial, which is still yet to be triggered. There is complete, I mean, the rest 2 being small and already configured. The threads have already run on them. So this is one more way to verify that so the concept here is like for the hot storage, hot, cold, and the other tiers which are still using the local cluster to transition your data into various different pools. This doesn't make any difference because the usage is still on the Ceph cluster. But the other thing is, if you move your data to the external endpoint, you see another section in the usage where the usage grows in the cloud tier, RGW.cloud tier, where the main storage still remains 0, but the data is actually moved. So we'll continue to look at that later. Yeah, I think it's still in progress, so it hasn't really moved the data yet to the external endpoint. So yeah. So let's take a look at the listing on one of the buckets where I applied it to move to the, yeah. I think I'll skip this part.
Does this feature also support?
Yeah, I guess. Yeah. Yeah. So since I know that live demo fails, but I didn't realize that a recorded video can have failures too. So if you see here, the other bucket where I applied a tape, moving it to the external endpoint, the data started to move, and there were a couple of objects that were already moved, and that's in progress. So now I'm trying to list on the tape library one point here is like in the tier target, I haven't configured the path where the target path on the external endpoint. So it created a random bucket for me, like default cloud tier cloud bucket, but I can still choose what bucket should the external endpoint have to copy the data into that cluster. So here, if I list on that bucket, there is the data being copied into this bucket from the local Ceph cluster. Yeah, so as I showed before, the data is still moving. But the interesting part here that I wanted to show here is listing the, So this is the list on the local Ceph cluster. With that option, the metadata is still maintained, but the object size is 0. But similarly, if we do a list on the tape library endpoint, we will get to see the actual data. Yeah. I was giving a wrong. It happens 2 more times, I guess, because it took time for me to figure out that the 2 backslashes were missing in the path. 1. Yeah, I couldn't edit it. Yeah, so exactly. So the data is present in the external endpoint while the metadata is still maintained on the local cluster. So I guess that's it. I hope I did not bore you with the demo, but could show something that I tried in my setup. So thank you. I would like to end my presentation here. Thank you for being patient. And do you have any questions for me or Artem?
Yes, thank you for your talk. I do have a question regarding the usage stats you've shown, because it showed the cloud tier. I do have some clusters in production with storage classes enabled, and they don't show me any accounting other than RGW main. And so far, I don't know if that there's any feature that actually accounts that. So is that only because of its cloud tier, or how is? Because I'm really interested in deploying it in production, but I can't account, so I cannot do that.
Yeah, I'll try to answer the question for you. So since in the other storage classes, the data is still residing on your Ceph cluster, right? So it's part of your cluster, but a different pool. The bucket, metadata, data, everything remains same, but it's just that you're using a different infrastructure to store your data. Right? So the RGW main is still populated. But in this case, since I'm moving the data outside the Ceph cluster, it is considered to be a different tier, and there it starts to manage the usage for you, which is not on the local cluster, but on the external endpoint. Okay, so yeah, it still shows the same data, but in a different usage stats.
Okay, so I was correct that it's still for local storage class. Yeah. It doesn't account yet. Yeah. So that feature is still missing. Yeah. Okay, thank you.
Yeah.
Thank you very much. And I have 2 questions. The first one is, I didn't get how the policy-driven automatic tiering is actually done. So
Yeah.
is it a Ceph feature, or is it scripts that you wrote?
No,
Or any
it's a
tools?
Ceph feature. It's
So-
a Ceph feature which
okay.
is still in testing.
Because
So sorry, I'll let you
sorry.
continue. Yeah, so it should be available from Tentacle, I guess. Tentacle and the
Okay.
later releases of Squid. Even I couldn't test it for the reason that, I mean, by the time I was preparing this, I didn't have a Tentacle setup in my local, but I'm definitely gonna do that after I'm back. But it should be available because I tested it in Squid 19.2.2, and the restore object method was not available, so it had an implementation error. So I have to go back and test it on the Tentacle or 19.2.3, I guess. I will test it out. So yeah.
All right, cool. Thank you. And the second question is, how is the actual retrieval from the cold storage to the warm storage, or from warm to hot? How is it done, or when is it triggered? Is it triggered at all? So, or does the data remain on cold storage once it's there, or is it somehow copied back?
As far as I understood this, so when you said the allow read through, at least for the restore with the get API, right? So S3 restore object API is completely different, where you trigger it based on the setting that you do it on the bucket. It's a method basically, restore object. But here, policy driven or the read through get, that you enable the config option, and that's when based on the number of days that you allow it for, the data is copied onto your store. I mean, in the locally, and then it is moved back again. It's subject to testing, so I have to test it out.
All right.
Sorry. Yeah.
Thank you.
Yeah.
Yes. Well, thanks for your talk. I think storage tiering is a very interesting subject. I'm wondering about Chorus for migration. I've done some migrations. Luckily, they're behind me now. So I'm wondering at what kind of scale would this still operate? Because we do see users who happily put 100 million objects in a single bucket. I don't know if they should, but have you also tested these kind of numbers and what to expect there in time, in downtime or?
I don't have like exact numbers, but yeah, in general, it's not in the slides, but you saw like we have a proxy and the worker components. They are communicating between each other, and it says that they horizontally scalable. It means that there is like multiple instances. So what missing is on the slides that they using database for communication. So we're using like Redis for it. And in general, when we tried like to test Chorus in our environment, like for the test cluster, we noticed like we always have a network as a bottleneck. So for example, when I add like, so we tested on Kubernetes, when we add like, when we scale pods, when we add more CPU or memory, nothing happens because it just takes a lot of time to copy like 1,000 objects in parallel. So in our case, network was the limit. And when we also like asked other people who use it like from a GitHub, they also telling that they using rate limit for production storage. So we're a little bit afraid because some of them expose this start migration API to customers. And for example, like what will happen if like many people will try to migrate their buckets at the same time. So it will try to copy like a lot of objects in parallel, and you end up with the network as your bottleneck. So that was like my experience. And the actual bottleneck which you may face is Redis. And the thing is, like for example, if worker will be done at some point, so it will not be able to process tasks. So and the queue will start filling up. And from my estimation, so like for 1 million tasks in the queue, unprocessed tasks, you need like 700 megabyte of RAM in your Redis instance. And yeah, and like 200 megabytes to store version updates for 1 million of objects or something like this. So in theory, you can plan, so it's quite easy to plan like your Redis memory capacity, like on the napkin, like calculations. But yeah, for scaling like a proxy and the worker, like from my experience, it's always the network, yeah.
Okay, well, thank you, interesting.
Okay, one more question regarding the cloud tier storage. When you're using a tape library, how is the latency handled? Like, it's not like a tape library will reply instantly with the data. You have to wait until the robot actually moves the tape. Is the request just stalled on the S3 API, or is it just like you call RestoreObject and it tells you, yeah, come back later and...
Yeah, unfortunately, the emulator was very near to my cluster, Ceph cluster, so I didn't really face any latencies because this is just a simulation, not an actual library. But then I think I have seen some latencies when you upload, when the transition of large objects is happening, for example, like 2 GB, 3 GB, they are very small considered to the workloads that we are running today. But I guess it is a bit slow, but I cannot give you the exact numbers because I haven't monitored that to that extent. But yeah, it takes time, yeah.
Okay, because it could take like minutes for the tape to actually locate the data. So, yeah. Okay, interesting. Thank you.
Okay.
So thanks a lot for your talk. Brilliant. I have one question left for you. There was displayed that they validate the stage of the replication between the buckets. Is there a real data validation mode or option available now? Okay. Fair enough.
Yeah, we just try to like list all the objects. We also try to do it like in parallel, and we only check in the data which is available in list object separation. So normally is like name, size, and e-tag. And yeah, and actually, I don't know if it's true for all storages, but for some storages, e-tag will be different if you will use like multi-part uploads, and the parts will have a different size. Because in this case, e-tag will depend like on the e-tags of the parts. So even if objects are the same, sometimes e-tag is not the same if a different part size was changed. So the best thing you can do is actually change that all objects that need to be there are there, all objects that need to be deleted are deleted, and they have the same size. So that's like the most like practical way you can do. Yeah.
Okay, thanks. Fair enough.
Yeah.
So, any questions, anybody? Obviously not. Thank you very much, Artem. Thank you very much, Sirisha. Yeah.